hopefully, now I'm gonna record this, just exercise, everybody should follow along, all right? So everybody has the ETABS, open it. So let's start from scratch, because all right, so if your ETABS is on, basically you're gonna just start out with file and uh, click the new model, right? When you click the new model, then you see that model initialization default. We're gonna start with the US customary imperial unit. So when you click it, you're gonna see this template, right? It's gonna kind of give us the convenience to set it up. If you have a building is very orthogonal, you can use it, but sometimes, mostly, you don't have the very uniform bay layout. So if you want to use this default, it's okay. Otherwise, I can just maybe kind of click the blank and start with a blank pages. So, but when I choose it, this is actually based upon imperial unit. So you see that unit is the first the what you have to choose, right? If you're working on international project, they follow the metrics. Better use either millimeter or meter, right? This is, I mean, in all the building in the United States, we're using imperial. You have to use imperial unit. All right, so this. Now let's see, go to edit. Since this is a building, we could do something. Doesn't have to be always one A, B, C, D order. And if you know that in all the content, you could just either A and C and D and F, and you can jump. I think eventually you get there. But what you need to do is, first of all, here, edit the story and grid system, right? So we're gonna first of all set up the grid and elevation, the story. That's a 40-story building. Okay, let's try. But we're not gonna build a 40-story today. It's just only one typical floor. So when you open edit story here, story data, and here is a grid system, right? So when you click the modify story, okay, default is show 4-story building, but for now simplicity, let's use a 15 feet, right? So I type this 15. So basically, all right, so 15 is a typical floor. I'm gonna just say okay. Now we need to generate the 40-story, right? So here, edit, so I can click this, continuously click, quick add the story. So I'm gonna create the story up to 40. When you add this, when you hit the quick arrow story, basically, yeah, they just referring using the floor below information. They keep the 15 feet as their tall or their floor height. So basically, at the top 40th floor, our elevation is 600 feet, right? It's easy. I mean, this is not engineering. It's just kind of, if you follow up, it's easy. Now we're gonna move to the grid system. So here, the G1 is grid here. Let me see. Modify show grid system. You can define X grid in X direction and Y direction. So here, I'm gonna just use default. And I'm gonna click add, and 0 coordinate 0 0 is the first, and the second I click this, but every 30 feet on center, right? So I'm gonna use in X direction 30 feet spacing. Then let me just click add. Somehow they automatically understand 30 feet spacing, so I keep adding. So this is my X coordinate and X grid. If you want to put the name 1 to grid name, type it, right? So this is you see that grid along the X line, 1 2 3 4 5 6, and I think Y, you could start out with 0 0 again, and if you add second, add it. But this one, let's say 45 feet, and middle bay maybe 30, so 45 plus 30, right? I mean, ETABS has a built-up calculator, so if you type 45 plus 30, they calculate it. And another 175 plus outer bay, I'm gonna keep 45 again. This one doesn't have to always my number. You could just do whatever you just want, right? So the alphabet A, B, C, D. This is kind of, let's say, the billing grid system I'm gonna work with, right? So if you're done, say OK, and say OK. So it's generate the grid for X, Y, and Z, right? It's easy. And you don't have to always complete it. You could use whatever, but you could just organize. I mean, this is something similar to other software and other tool. Now, okay, mostly our works is on plan basis because we're gonna drop the column through the wall, and we're gonna draw the beam and gutter on plan basis. So I'm gonna close this. I'm gonna keep it on a plan view. You see that they show the story 40, but I'm gonna choose a plan key button here, plan button. I'm gonna work on the story 1, right? Plan and story 1. So see that story 1 elevation is 50. All right, everybody's with me here? Okay, if I remember correctly, I'm gonna draw the column first, right? So here there are shortcuts. Obviously, every shortcut has a command here, but I usually play with the shortcut. So here, when you hover your cursor, quick draw column plan 3D, right? If you click it, I mean, it's asking show the properties. A means auto selection property, A dash lateral column. And there is something offset command, which is okay, but maybe we could choose, let's see, what else? The default, ETABS has a default section property. A means auto selection. This section property has a group of all the steel section. We can use ETABS to design and choose the section after we complete the analysis and design. So here for column, let's say, let's choose lateral column. Again, if you're interested, go to define and section property. If you open the frame section, you see that here is all section properties, right? And A means auto. So if you want to see this section properties, what this section property contain, if you click modify show, you see the auto lateral column property has auto selection list. So the ETABS, if user use this auto selection properties, ETABS gonna choose the available applicable sections while you're designing the members. So go back. I'm gonna go back. So I select lateral, keep the lateral column. Let me see. So this. See that? Since you have a grid, I mean, when you click and drag it and let it go, and ETABS automatically place the column at the intersection of grids. Cool? Cool, right? All right, wow, simple. I mean, Revit has some similar feature, but obviously that's why, but remember that the grid is something in collective works because we propose the column location, but sometimes based upon architectural layout, right? Mostly it's not going to be lined up. Sometimes column is kind of staggered. I mean, so sometimes you maybe end up with many more grid, but if you have a nice simple grid system, your efficiencies is kind of be crank and move up. So because some simplicity. All right. So I drop the column. When you drop this, basically this column is below the first floor. So when you put this, you see that? There's a column, right? They drop the column in space and vertically. So on the plan basis, when you draw the column and the wall, it actually drop the column and wall below the designated floor. right? So if you want to see the 3D rendering, maybe here, yeah, extruded view toggle, right? Let's see. Yeah, so if you turn on, it show the profile extrusion of this section. Here. So this is a frame object and shell. Since we don't have a shell object, I click this, turn, maybe click this. Yeah, click this, on and off, extrusion. All right. So visually you confirm it, whether you properly assign. So I'm gonna turn off that. Since this guy is on, usually doesn't let me. All right. So this is 3D. I'm gonna go back to the plan, story one. All right. Now I'm gonna draw the beam encoder. Let's see. Since let's see. Oh, I'm gonna draw the girder. So the beam. So let's see. Beam draw. I may try both, but let me try this. Okay. Okay, this line. Let me see this. Maybe. Yeah, this one works. Okay. Let's try this. Let me see. So if I use a quick draw beam, hopefully it works similar way, right? This one. Quick beam draw. If I click it, same thing. This time I'm gonna choose here a auto selection composite beam, right? Properties. So because we are designing composite beam, so I'm gonna use somehow section properties for the composite beam. And moment release. We've been talking about simply supported beam. All the beam is only taking care of carry the gravity load. Gravity loads. For now, we don't rely on this beam and column contribution to the zero contribution to the lateral stiffness. So we're gonna choose pin here, right? The pin is gonna be released the moment, so it's gonna work like a simply support beam. You've been learned simply support beam, right? Pin roller, that is reflected in here. So okay, hopefully, let me see, drag and drop. Okay, let's see. Oh, okay, it works. So you drag and drop so that you add the beams between grids, intersection point. Cool? Easy, right? But again, this is very simple. But most likely my real work is not everything is lined up. So sometimes I draw the beam clip by clicking and adding manually. But depends on your real knowledge. So you need to just practice sometime 0 degree, 90 degrees, 27 degrees, right? So this is kind of workflow. You are currently taking this one step, right? Sometimes it looks simple, but sometimes it's stuck because obviously you need to know, you need to experience all 360 degrees. Then your knowledge, your mind, you can kind of get figure throughout, up and down, and anyway. But if you know the one path, you don't have a choice, right? So obviously, that being said, practice, okay, is the only solution, but different way, because you're gonna somehow stuck. Next time when you started from the scratch, you may stuck. Well, what did I do, right? Just try to figure out, struggle. That's how you learn. Because if you know the one direct in the past, you're never gonna find out. All right, now filler beams. Here, let's see. Now quick draw secondary beam. Okay, if that works, pretty much, okay. If you click this, okay, automatically show composite beam, number of beams. Because this is 30 feet, right? So our beam spacing, we want 10 feet. Again, 10 feet. So I need only 2 beams, right? So this setting is parallel to Y. So if you hover around, it shows this, right? Oh, okay. I can click it individually. Let's see. Oh, it works too, right? Drag and drop. You can add all the beam. Everybody finish up to here? Let me know. Shout it. Yes. Yes. Right? Yes. Easy. Wow. Okay. Fun. Somehow you need to over gesture. Sometimes your life is kind of boring, but somehow I want you to somehow find that energy. How to build the energies, attract energies. I mean, I think you need to either speak and you have to move around. That's why we do some sports. I mean, now think about it, how you get the high performance mentally and physically. How? Think about it. Otherwise, your routine daily, every day, I'm tired. I don't know. Do I have to go to work? Let's think about it. There must be some way you can just, right, change better. Because I really realized it. I try to kind of, because getting old, you get some pain here there. It's not, you know, always saying. I want you to at least figure it out. All right, everybody's up to here. If you're interested, put it 3D. Again, put the 3D. All right, render. Oh, this guy is always okay. Turn on. Okay, so rendering. Oh, wow. Okay, cool. Right, 3D. I mean, it's always worth it to look at in different angle. Okay. Okay, it's very quick, easy. Now go back to plan again. Now we're gonna add the slab. I'm gonna turn back off this rendering. I mean, you can turn off, you can use basically this checkbox, right? If you click this checkbox button, you can turn on and off individual column, beam, brace frame, wall, something like that. There are a lot of properties you can turn and on, turn and off. We're gonna talk about it later, but yeah, there are other features. So now one thing that I want you to show you, because okay, we chose a pin connection. So beam connection is all pin connection. So how do I know it? Because this is actually connected, but let's go to checkbox. In the object, the second tab, object assignment, frame assignment here, right? Here is end release, right? If you check this, I mean, we want to make sure, how do I know this beam is pin connection or not? So if you check the, turn on the end release, the beam has a moment release, pin connection, show the circle at the end of each I, J, each end, right? So this is obviously representing this pin connection, so this is simply support beam. Okay? All right. So since we use default auto selection section property, okay, if you want to, okay, turn on, see, if you want to see the what section size, the ETABS we are currently assigned on use, go back to again, checkbox, object, here, section name. So frame assignment, section name. So if I apply, you see that? So this is section properties. Currently I'm using it for initial study, run it. So let me zoom in, right? So since we chose auto composite beam, this section property has a series of the steel sections, right? In ETABS, choose medium the sections and for their initial analysis. So it shows W 18 by 48, but it depends on what section properties are you using it. But since we are using auto composite beam section property, ETABS will choose 18 by 48 as their test trial section properties. All right, everybody up to here? All right, now we're gonna draw the slab, right? Now our slab is not concrete slab, this is metal deck slab. So briefly, let's go check this define. So I mean, as you know that we need to kind of understand the material properties. Also section properties, all section properties should be associated with the material properties, either steel and concrete, depends on their concrete strength, or depends on their steel strength, right? Depends on material property. So here is the material properties, but here section property, there is a deck section. This is a metal deck slab. Section properties, deck section, if you click it, there is a one default deck one, right? Let's click open it. So default deck has a, I mean, default is type is fill means a composite slab. So you see that this is metal deck with a concrete fill. So fill means it's a concrete slab on metal deck properties. So we're going to use it. So here, H sub R and T sub C, right? The metal deck depth is 3 inches. We're going to use it. So HR, right? Which here, default rib depth HR is 3 inches, right? Do you see that? Here. And default, they have a 3.5. Now, let's use this. Let's use a 4.5 because we have a normal weight concrete material. So let's use 4.5. So this is normal weight concrete. Now, most important things, name convention, sign convention, all right? All right, you are managing entire maybe 40-story building, all the section property, material properties, so all name, come up with a very short kind of name with the prefix. Otherwise, you're gonna end up with, wow, this is a long name. Sometimes software, ETABS, Windows doesn't recognize this long name. I remember that Windows doesn't recognize a very long name. How many words maximum cap? I think Windows, well, type it. I remember that there was a limitation of this word. So here, 3-inch metal deck, maybe, right? Metal deck, if you want metal deck, right? 4.5, 4.5 work, concrete, right? Or something like that. You can come up with a various name, but doesn't have to be always this. So but I'll just use 4.5C. Metal deck, slab, 4.5 topping concrete. All right. So this is name. So now I have a deck properties. Now, do I have to use this? Okay. The same thing is a quick draw, right? If you click the quick draw, and again you're gonna choose 3-inch metal deck and 4.5-inch concrete. You're gonna choose the deck properties. Just we created, right? So since this is a quick draw, seems like they just add the section like this, the slab bay by bay based upon boundary of column grid. So if you want to do it, right? Same way, right? That means you are adding the slab, say bay by bay, right? Right? So it's fine, but sometimes I don't want this. Instead, I'm gonna undo. I may be using this one method, right? Instead of quick draw, I'm gonna click. See, click, hold down, and click. Come on, where did? Oh, it's frozen. Oh, let me do this. So instead of just bay by bay, I'm gonna draw. Okay, it's on my computer. You can click. Oh boy, what's going on? Oh. All right. So you can click. Okay, click and click. Right? To click, you can draw the big slab instead of just bay by bay. Right? Everybody got this? Fun? Right? Okay? So one thing that you need to, this big, if you have the beam and frame layout is all parallel, this method is much easier. You could use it quickly, right? But if you have the beam's orientation change, you cannot use it. So here is the thing. We talk about metal deck. It's kind of colligated. It has a one-way direction, right? So metal deck is folded. It should be placed perpendicular to the beams. Otherwise, it's going to fall down, right? See that? It's folded, right? So that metal deck should be placed on series of the beam on top, right? Physically. If you rotate it and put here, your colligate, they don't have a stiffness, it's going to fall down, right? So always metal deck, when you place, so this arrow should be perpendicular. Got it? Right? This is numerically perpendicular. If you want to somehow change it, Yeah, here is a local axis. So I mean default is 0. So 0 means your orientation. This plate axis is this is 0, 0. Okay, everybody up to here? Okay, move on. Okay, since we have a 20 minute, let's move on. So at least we're gonna talk about same thing. So far, what did we do? Only geometry, right? We just drew the geometry. Okay. In order to do that, we need to choose a unit. We have to set up the grid system, and we start out draw the column and border and beams and slab. Oh, for your information now, since same things, we're gonna end up with using the concrete wall. So let's draw the wall. Uh, okay. Typically, if you have a wall, okay, I mean wall is gonna carry the load, so you don't need to add the steel column. So for these cases, for information, let's say, yeah, I'm gonna just choose this. Hold on. Hold on. Okay. I'm gonna select this, delete it. Oh, what's happening? Okay. Select. I'm gonna select this bay, right? So I'm gonna draw the wall. So here, quick draw wall, right? Do you see that? Same thing. Hit the draw wall. Oh, here, quick draw. Okay, quick draw. So wall one is I think 12-inch wall. I will just keep it 12-inch wall. Section properties. Let's see it work. Oh, okay. Because since I have a grid, I can click, click, click. I can add a wall. Okay. Eventually, we need to cut the wall because we need to allow the wall opening to access this. But obviously, right? You can draw the wall like this, same way, right? But in realities, I mean, this wall, for example, because I think typically we need to access, so wall should be kind of manually draw something like that. I click, click, right click, 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 something like that, right? So now I'm gonna delete, choose delete, and instead of using quick draw the wall, I'm using draw the wall, click, 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 right click, 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 right click, 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 right click, left, 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 right, left, left, right, escape. So I I draw the wall like this so that I assume this is actually corridor elevator hall, right? So assume this is series of elevators, stairs, same thing, elevator or some equipment. So because actually people on a circulate around the core to get to their office, but in order to access to the elevator, right? So eventually, that's why I draw the wall, and because we cannot put the wall, it should not be the full full wall, otherwise we cannot access, right? So far we just basically practice draw the geometry by using ETABS. You got that up to here? Okay, right? We didn't do any engineering, just based upon understanding of the structural system and background. We just lay out vertical elements, which are column and wall and beams. All right, so if you want to put the 3D, look at this. Yeah, just want to check the extrusion, turn on. So you see that 3D rendering, right? It looks like that. Okay, cool. Right. So we have a 15 minutes. Let's set it up. Oh, we're gonna sprint it. So the we just finished the geometry, but the one thing that I'd like to add, because is our general practice, because this is concrete wall, concrete zone. So typical construction teams gonna erect the concrete wall first, right? Ahead, and eventually this wall is need a concrete beam. This one is should be concrete beam. So we're gonna tie with the concrete beam because the wall is a vertical element, have to brace it together. So we're gonna add a concrete beam. Same things. I'm gonna choose to go back to the story one, and here zoom in. So I'm gonna let's draw the concrete beam as well. Oh, why this zoom extend doesn't work? Okay. So adding the beam here, because now not in intersection, I'm gonna draw the beam from here to here. I choose the manual draw the beam. Okay, do I have a concrete beam? Okay, concrete beam. I'm gonna choose concrete beam. Since concrete beam constructions, this is a monolithic construction, so it should not have a moment release. This is continuous member, right? So concrete beam should not have a moment release. So keep it, continue, and draw the zoom in. Zoom in. Why this zooms? My computer. All right, let's turn off this while I'm recording it. Yeah, this one doesn't work. All right. All right. So I'm gonna add a beam. Right. Or maybe okay. So recording is a little bit obstruct. Okay, checkbox. I'm gonna turn on the nodes joint. Okay. So if you turn on the nodes, maybe better. Usually this actually snap. This recording operation is really doesn't show snap. All right. Let me click the beam again. Okay, now. All right. So I'm gonna draw the concrete beam by clicking, click, right click, left, right, left, right, left, right, and scroll, pen, click left, right, left, right, escape. So I draw the concrete beam, right? So up to here, basically, because this is a high-rise building, we are using concrete wall. Since we placed the concrete wall to align with our planning requirement, because this is elevator hall, so you cannot put the wall. So I just drew the wall, most likely see an I-shaped type of layout, and I tie with the concrete beam between tie the walls with the concrete beam. So now, so this is the general the model, which inside the slab is most likely we're gonna end up with a concrete beam, gravity frame beam. We're not gonna pay attention here. So, but this is inside this concrete wall is more. This is gonna be likely is a concrete construction. So it's a concrete slab and concrete beam inside. But we're gonna focus on outside composite beam framing outside. All right. All right, are you ready? So when you put the 3Ds, what you notice this, because this is most, the slowly one, when you drop the column, the ETABS automatically assign the boundary condition, right? So it's a pin boundary condition, you see it? Boundary condition, right? So basically this model is ready. If this grid is bothering, you could turn off the grid, Control D, as a David, D. You can turn on and off, okay? Right? Control D, turn on and off. Control D as a David. Control D, all right? So now we're gonna assign the loading. So make sure you have a boundary condition here, right? Now let's look at the loading. So define, go to define. We have a 10 minutes, we need to move fast. So, right? So here, loading pattern. When you open the loading pattern, default, you see the dead load and live load, right? Dead load is structural self-weight, structural member self-weight auto calculation. So we should have a multiplier 1 means ETABS will automatically calculate that they are using their section property and material property, they calculate the self-weight, which is cool. You don't have to calculate, right? And so, and the live load is default as well, but here, for composite beam design, we're gonna add another superimposed dead load. We talk about it. So superimposed dead load. Here, we have a type superimposed dead load, right? But should that include the self-weight? We don't want to double dip it. You can add it, right? I just type superimposed dead load. Choose the superimposed dead load type. No modifier. Just keep it as 0. So I add it. One more construction live load. So I'm gonna create another live load. During the construction phase, we are expecting some live load. So here, construction, here, type, right? You see the construction type? So you add it. So basically, we're gonna play with these 4 load cases, right? 1 is dead load, self-weight with multiply 1. Live load, yeah, so we keep it live load. Superimposed dead load. We talk about floor finish and ceiling and machines, but doesn't move around, but that's not structural element. All right, very important. Don't confuse with the structural, non-structural. This is bottom line. You should know that. You learn, right? The construction liable load is during the constructions, there is something material that people move around. So composite beam design is actually is in twofold. During the construction, you could think of it. You erect the column, you erect the girder, you erect the steel beam. Now you put the metal deck, right? You weld the stud, wire mesh, you pour the concrete. Okay, at that time, concrete doesn't have any strength. It's a weight alone. It's concrete, wet concrete, right? Doesn't contribute any stiffness, strength. So that is a construction phase. So that means only steel, bare steel should support those loads, right? After concrete is cured, we have a composite action, much steep, strong floor framing is we gain, then we are using, that is a permanent condition. We are designing for all permanent load, that superimposed dead load and live load. So, okay, so we're gonna move, close it. So we just create the load cases, right? So now we're gonna assign the load. So if you have a slab here, you select this. I have only big slab, one here, right? And go to assign, right? Select the slab. We're going to assign the load. Assign. Since we are using uniform area load, we're going to use a shell load here, right? Shell load. And here, uniform, right? So, okay, that load is self-weight, so I keep it. I don't want to add. Instead, superimposed dead load, I choose, and I'm gonna assign, okay, something 20 psf. It's the load direction is gravity down, so it's pointing down. So apply the uniform 20 psf. This is designer's guideline, designer's decision we use. We estimate our superimposed dead load is 20, so I'm gonna assign. So you see that 20 psf is assigned, applied to this whole area of the slab, right? We are assigning the loading. If you want to assign another loading, either you could click it, or there is a previous selection key, so you can click this. So you select the previous selection properties. So now we're going to assign the live load, right? For now, let's assign 100 psf. Pound per square foot. So this is a commercial office. Then let's use 100. So I'm going to assign that. You see 100 is assigned. Repeat. Select this. Now construction live load. Construction live load. During the construction phase, I assume something 20 psf live load. People walk around. They carry the material. So the steel members All right, right. When the concrete is poor, people still work along on the metal deck. Concrete is wet. The people move around the equipment here, there, right? We need to address those. That moment, the steel alone, steel beams have to strong, strong enough and stiff enough. But after concrete is cured, fully cured, the beam and concrete is really stitched together, right? That permanent condition is we are also checking for permanent loading. I will explain that after that. So I'm gonna assign 20 PSF construction live load, right? So assign it. So when you do that, it's ready to run. So basically geometry, again, repeat. I'm gonna keep repeat it. It's same thing. Geometry, grid, unit, right? When geometry done properly, boundary condition, moment release or pin connection at the support restraint. Define your load pattern, load cases you want to use. We set up self-aid, superimposed dead load, and live load, and construction live load. Now, time to run it, run it. Here is the button, run analysis. Okay, I'm going to use here composite beam, name it. We have almost 4 minutes. So I'm going to just show you through quickly because we're out of time. So when you run it, obviously you need to check the bending moment and shear diagram. So here, default, you show the deflection. I'm going to put this one on the plan view. Plan view, okay. So this one, I'm going to check the moment. So, okay, dead load. Yeah, this is deform shape. Okay, I need to, yeah, force. So I click this, see the member force diagram, right? I keep a moment diagram, dead load and moment 3. So first thing, okay, if you want to turn on the value, turn on the value, right? So first thing, I want you to just pay attention from now on. We as an engineer, when you model it, we make a lot of mistakes because we click the wrong point. Maybe it looks connected, but it's not connected. Then you will see the weird moment diagram or this weird displacement, right? This is QAQC job. So you need to always observe what and do some QAQC, make sure everything is correctly click and develop. Right, this is one of kind of QAQC. When you turn on the moment diagram to the dead load uniform load, which you see the moment diagram. We exercised last week, right? WL squared divided by 8, uniform load on the beam, right? So uniform loading time trajectory width make a line loading. If you have a line loading, W times L squared divided by 8. So you should have the maximum bending moment, right? Because we are using uniform load instead of point loading, so you should. And then also the shear force diagram, obviously W times L divided by 2. So because if this is that case, shear force diagram should be linear, right? Right? So this is shear force diagram. I want you to just take a look at it now. So we're gonna set up the load combination. So after you check it, go to define, and you're gonna build the load combination. Since we set it up the load pattern that ETABS recommend, so we can use the default here, default design combination. If I click it, here is the composite beam design load combination, composite beam design. So if you click it, so ETABS and set it up the load combination here, right? So you see that if you hover around, you see that typically S1 is 1.4 that. S2 is 1.2 that plus 1.6. This is most a permanent condition load combination. But construction load here, C1 is construction cases, 1.4 that doesn't include superimposed dead load. And C2 includes 1.2 that, self-aid, 1.6 construction live load. So C1, C2 is construction phase condition. S1, S2 is a permanent condition, right? So we're using this. So now final touch is here. Go to design. When you set up the load combinations, go to composite beam design. For now, I'll hit the start design check. All right. So when I hit the design, I think ETABS already know what is the bending, maximum bending moment, shear force. So they already analysis done. This is a design module. They choose the applicable member, whichever, right? It's because we using auto selection. So you're gonna get this information briefly. The ETABS proposed choose, okay, W21 typical 21 by 50, number of stud 39, camber 2. All right, we'll click this. All right. Yeah, this recording is actually keep bothering. I cannot click this. All right, let me just move this. Let's see. Yeah. All right. So this is the end of the class today. So if you actually design, I mean, ETABS choose the applicable member sizes. So among the auto selection, okay, this beam is all working, right? Lightest member to the heaviest member, right? So 21 by 50 works, okay? 21 by 55 works, yeah, obviously heavier work, and deeper 36 works because they're all in our auto selection properties in the list. So it shows all the applicable member sizes, number of stud, and selection camber, right? So this is kind of procedure for composite beam design. We cover entire, but I'm gonna post this video, and you guys practice a few times. But team should start layout, come up with the final project.